All right, take two. This video is going to show you how to calculate the acceleration due to curvature in your Desmos roller coaster. So the acceleration due to curvature is equal to twice the change in the height. So that'd be like one height value minus another height value times the second derivative, which could be f1 of double prime, which is the single quote tapped twice, evaluated at a certain value. So maybe we want to look at a certain value, like x1. This is function notation over here. That's why we have the parentheses. And this is capturing that subtraction and then multiplying. That's why those parentheses are there. We're going to put in values for y2 and y1 as we go. And then we'll work out what the where the most dangerous places are and only calculate it in those places. I'm going to remove this line and then build up this line that's above it. So right here is a dangerous spot. And that is at the bottom of this curve where we start in way up here and build up speed as we roll down until we get to this point. And then right there, this curvature is so great that it's probably going to send people into blackout during that part. So we're going to take a look at that. So we'll have twice the difference between the two, which is starting from the top. We could look at what the value is over here. It's at -2. So I'm going to go from the first function evaluated at -2 and subtract the same function, because we're still in the red function, evaluated at, I think it was 1.267. 1.267. There is the height change doubled. So it drops from about 10 down to about 3, and we double that. And then we're going to multiply that by the second derivative, which is a measurement of how curvy it is. And that is f1 double prime evaluated at the x value of that point, which is 1.267. And that is way out of bounds. We wanted this to be under 5, and we are at 23. So we're going to work on that. What can I do for that? Well, instead of starting up this high, I only need to start just a little bit higher than the next curve. So let's try starting at 0. What happens if I reduce this down to 0? Now it's nice and low. So removing all of this startup is a nice solution. So instead of having a great change in height, I can have a smaller change in height, going from here through this curve and having enough momentum to make it over the second curve. Now let's check what the acceleration will be on the second curve. I have this template started, but I'm going to need to change a couple things about it. So I copied and pasted. I'm still starting at f10, so my drop-in is still at this point. And then instead of evaluating f1, I'm now onto the blue curve, which is f2, my second function. And the x value at this point is 2.571. So 2.571. And again, I'm going to look at 2.571. It's currently undefined because this is not the right function. I want to be on 2. There we go. It's negative 1.879, which is within tolerances. So we want to get it closer to 0 than -2. So we want it slightly larger than -2 for it to still be within tolerances, because we do get to add gravity's 1g to that. So the rider would only experience negative 0.879 after we add 1g to that piece. We have one more place that I'm really worried about, and that's down here. And that's going to be dangerous. So let's take a look at that one. You can copy this, paste it in again to look at this last place. And it is already function 2 because it's all blue, and that was at the x value of 5.712, I believe. 5.712. Numbers are surprisingly similar. And that's dangerous, so we can't have that. So what do I do to change that? Is the next part of this. I'm going to have to either reduce how far up they start in from, or change the curvature here so that it's broader. So I'm going to extend that out. I'm going to try extending it out instead. So I'm going to look at function 2, and the ones that will change how broad it is there are either A, I can reduce A, or B, I'm going to undo, or B, if I increase B. If that drags it out. And both of them are useful. So I'm going to try reducing A. I'm going to slide it over a little bit and up a little bit. Let's see. That's close. So I can come back in and fix this juncture later. But first I need to make sure that my curvature down here isn't deadly anymore. And if I come over here to this point, it's now over at 6.212. So I have to change where I'm evaluating it. And yes, I could assign this to a variable and slide it around with a slider. I encourage you to try that. Oh, it's just a little bit too high still. So I'm going to drag that out a little bit more. And oops, undo. Let's get this one down just a little bit more. Slide it over a little bit so I still have about the right slope right there. That looks pretty close. So I'm going to play with that a little bit after. And I'm still just below the starting level of 0 to come into this curve. And my new valley is at 6.312. So I come back to where we're evaluating that. Let me change that to the new value and see that, well, look at that. I'm just under tolerance. So this is now safe. And I can go back up and adjust my domain for the first one to what we had just decided was safe for starting here and rolling down here. And that's the kind of work that needs to happen to fix the acceleration, to make sure that at the key points, you don't have dangerous accelerations. I still have to go back and fix this juncture, and you can see how to do that on the previous video. Thanks a lot, everybody, and I'll see you in class. I hope this helped. Bye.